Okay, so I'll start with today's discussion with the second case. Second case. The second case I will choose uh, hold on for a minute. So we discussed critically damped case in the previous class, if I'm right. Critically damped system, which means theta equal to 1. Sorry, that was case 1. So this is done. Critically damped system. So we'll proceed with the over damped situation now. Over damped system for which zeta is greater than 1. So what is the C of t for this? Do you expect the same expression of C of t for this also? So whichever we had derived for critically damped case, will it be same as this? Let us see what difference it will be. So we start with the first step again. Let the second order, standard second order transfer function is given by this omega n square divided by s square plus 2 zeta omega n s plus omega n square. So when you take the input Laplace on the other side, we get 1 by s. It is because of the unit step input. Fine. So let us get back to some whatever work we did. We know that for zeta greater than 1, everyone please concentrate here. So we discussed in the previous class that for the case where we ended up with zeta greater than 1, which is 1.124, we convinced ourselves that the roots are real and different, which is minus 3 and minus 8 here. Okay, so that must be clear to us. The roots are real and different. There is no imaginary term present in the roots. Fine. So therefore, for zeta greater than 1, the roots or poles or characteristic roots, whatever you call, are real and different. So before proceeding further, everyone can think of yourself how to proceed with the derivation. Let us put a generalized expression for the roots. Okay. So here's one important thing I will be doing. I am writing the roots, expression of roots, expression for the roots of this transfer function. I hope everyone can recall this. We did it in previous to previous class, and we wrote the roots as minus alpha plus j omega d, j omega d. And I had explained what is alpha and what is omega d. Omega d was called as frequency of damped oscillations, if you can recall. So what was alpha? Alpha was minus zeta omega n plus or minus omega d expression is okay. Sorry for that. There is some skip. Oh, fine. Okay. Minus zeta omega n plus or minus j square root of 1 minus zeta square into omega n should be there. So this is a very simple step. So I have skipped video just to save the time, and everyone can follow this. There is nothing complicated derivation here. No complicated derivation. It's very simple. So we know this expression. Anybody doesn't know this expression, how it came? This expression. So we know this, everyone know this. So I'm making a very simplest modification here, that I will take this zeta on the other side. I'm multiplying with a minus sign. Or in other words, you can say when zeta is greater than 1, obviously we have a complex term here. So we can make it real by taking zeta outside, j outside, and that j and this j will get multiplied. We again have a real number. We again have a real number here. Fine. So this is how we end up with this last expression. I have taken this zeta on the other side. Fine. So only when, if and only if zeta is greater than 1, this whole expression is valid. So it's not a much complicated mathematics, I feel. Okay. So this zeta and omega n is a real number. There's no doubt. So again we have a real plus a real number, which is a real number, or we can call it as a real root. So both are real roots. I will call the first root as s1 minus zeta omega n plus omega n square root of zeta square minus 1. This is the first root. Second root is minus zeta omega n minus omega n. Under the square root we have zeta square minus 1. So there are two roots. Any clarification needed till this point? Anybody wants to ask any doubts, or you want to look at these terms again? I'll wait for a minute. So we are about to find the expression of c of t for zeta greater than 1. And we know that for zeta greater than 1, the roots are real and different. So what are those roots? If you write the generalized expression for those roots, we will end up with this expression. This was our previous derivation, in which if I substitute a value for zeta which is greater than 1, I suppose to show that the imaginary parts will become a real value. So for that reason, obviously I need to make some shift here. That shift will cancel this imaginary term, and therefore we will have a complete real value. And one can easily look at these two terms that they are real but different. Real but different, not same. So one can quickly highlight where we are making a key change in the derivation as compared to the previous derivation. Fine. So this is the key step. It's a key step because if I write the expression for real values itself, my next procedure to find c of t will be quite easier. That's why I am following this method. You can question and try your own method. So there's no objection from my side. So let me rewrite the expression for the standard second order transfer function with input as follows. So this is equal to omega n square divided by s plus s1 into s plus s2 into 1 by s into 1 by s. Is it correct? Can I write like this? Can I write like this? Omega n square divided by s plus s1 into s plus s2 into 1 by s. So two roots are, okay, sorry. Just hold on for a minute. There's a very minor mistake here.
S minus.
Yeah, this what I'm supposed to write is, when I say the root of this equation is s1 and s2. Okay, there is a sign convention, sign mistake. You have to make correction in your notes. Instead of modifying here, you please write minus s1 equal to and minus s2 equal to. So that will correct everything. Okay, I had made a small mistake here. So if I write like this, it quickly gives us information that minus s1 and minus s2 are the roots. So for that reason, I will write minus s1 is this root, minus s2 is this root. So please correct in your notes. This is minus s1 equal to, this is minus s2 equal to. So with except that, everything is fine. Okay, next we'll follow the partial fraction method to find the Laplace inverse, the simplest way. The simplest way is to find ILT using partial fractions. So everyone please try it out. Try to find ABC. Try to find ABC using partial fraction. I'll give you the answers and give you 5 minutes of time. 5 minutes of time. Meanwhile, I want everyone to try this. Please don't copy as it is. Because in the previous derivation, I have found the value of constants. For this derivation, I want you to work it out. This is what A and B and C are. Okay, start it quickly and please find the constants A, B, and C. Take your time, and if anyone gets your answer, let me know. Everybody's getting? Anybody is trying? Is it lengthy? Karthik Patil?
Sir, I got C equals to answer. I'm doing A for A, sir.
Then for A and B, okay, fine. Lakshmi B. Lakshmi B.
I'm doing, sir.
Okay. Ronak.
Yes, sir.
Got the answer or trying?
Sir, doing, sir.
Okay, so please try it without fail because it looks simple, but when you try, I mean, your writing may make some mistakes. So please try it without fail. So is it okay? Like, can you copy this and you can you verify later? Because for others, I have done the partial fraction procedure and it may take more time for me to explain. So for only this particular case, I will skip the derivation. Okay. For others I have done, you can follow from there. So you can take a note of it and we'll proceed further now. So let us substitute these values. This is a constant, this is also a constant, C is also a constant, because if you substitute any value of zeta which is greater than 1, this is a constant value. I mean the whole A, B, C, all three are constant real values. So please concentrate, stop the derivation for a while, you can try it later. Then to write C of t, what I will do is I will write C by S as C only and A by S plus S1 as A into e raised to minus S1t plus B divided by S plus S2 as B into e raised to minus S2t. So where A, B, C constants are represented here. Represented here. Fine. So this is 1 plus something plus something. Two terms are exponentially decaying terms. So please try to guess the behavior of the system from this explanation, I mean this expression. So C is 1 and the other two terms, forget about these constants. Okay, there are some constants but not ignorable. They will have some finite values. But the term e raised to minus S1t and e raised to minus S2t, since S1 and S2 are also real, these terms are called as exponentially decaying. So why it is called as decaying? Decaying means reducing. So exponential reducing means if the independent variable is increased, okay, if the independent variable t is increased, the effect of these terms will die out or will decay or will reduce. That's why it is called as exponentially decaying term expression. So when t is 0, obviously we will have the value of this as 1. The value of this as 1. But if t is say 10,000 or 1000, you can use your calculator and check it out that it will be 0. Okay. So as t is increasing, the effect of this exponential term is going to reduce or die out completely. So let us proceed further. When this exponential decays are dying out, the final value remaining is constant. So as time increases, we have only C, which is equal to 1, the final value. So the other way to check this out is assume some value for zeta, which we considered in example, and assume some value for omega n, which is again we had considered in the example. Substitute that in this expression. Okay, then you will get the values of A and B, and then you can plot the graph of C of t versus t as shown. So just by making a simple tabular column. So once you calculate the C of t for all the t values, again you will end up with this type of performance where our output is gradually increasing and settling down at 1 unit. So unit step input, it will settle down at unit. Okay. So the key observation you can make is there is no oscillations present in both previous and this case, critically damped as well as for the over damped case. Fine. So this is your part to calculate. Okay, I will leave it up to you. You can cross verify with these values of zeta and omega n and try to plot manually. So this is what runs behind the software. Okay, when I write step G in the MATLAB, this is what is going on. It will calculate an inverse Laplace transform. It will substitute all the values of t. It will then make a plot. So I want to ask one interesting question for everyone. Does our brain calculate Laplace and inverse Laplace, which we don't know? Okay, what I mean to say is like when we look at some system, we can guess its response without making any calculation manually. So it means that our brain does everything at the background, okay, without our knowledge. Fine. So that's an interesting part of the control system,
Sir,
real systems. Yeah,
sir, when we guess how a system behaves, it's rather by experience than some process, right, sir?
that's
I mean,
what.
we have observed something like that, but there's no processing. We are
Yes,
comparing that, sir.
exactly, exactly. It is both way. It is correct. I will say. See, what happens is for the first time before watching, it makes some guess definitely. It is by calculation only. And eventually, when you encounter such scenario or such environment frequently, your brain will learn that. Okay, because first time when you ride bicycle, okay, it is at the back end your brain will calculate and apply required pressure. Fine. And eventually, when you encounter with a bicycle frequently, your brain will learn. That's what actual machine learning is called as. You're training a system. You're training a system with huge number of data and teaching the system to what to do when a situation like so for a specific situation, what decision has to be made. So that's what you are doing in machine learning. Fine. So it's both way by experience, but before experience there will be definitely some calculation. I hope I convinced you. Whoever asked the doubt, Mister.
Yes, sir. Yes, sir.
Yes. Okay. Fine. Fine. We'll go with the next case then. Please try whatever is left in the derivation, like calculation the inverse Laplace and all. Take your time, but do it. So we'll go with the next case. Case 3, undamped case. I choose an undamped scenario. Yeah, I kept the underdamped last derivation. So let us finish the undamped case where zeta is 0. So when zeta is 0, we already know that roots or the poles or the characteristic roots are pure imaginary. So let us see what we have. C of s by r of s equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square into 1 by s. Oh, sorry, 1 by s. I'll be putting it later. So substitute zeta equal to 0. What we will end up with? We will get s square plus omega n square. So C of s equal to omega n square, s square plus omega n square into 1 by s.
Sir, are you sharing the screen?
Oh, sorry. Sorry for that. Really sorry for that. Okay, fine. So C of s by r of s equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. So substitute zeta equal to 0, we get omega n square divided by s square plus omega n square. So now apply the input. You will get 1 by s because of the unit step input. So how to get C of t now? Again go for the partial fraction to find the inverse Laplace transform. So how to write partial fraction? Can anyone tell me? Any diploma student? Can you tell me how to apply partial fraction for this? Any diploma student? How do you apply partial fraction if you have a second order polynomial in the denominator? Okay, that's fine, but you should work yourself. You should know everything before attending the class. So we have omega n square divided by s into s plus omega s square plus omega n square, which can be written as as plus b divided by this plus c by s. Okay, in partial fractions. Then omega n square equal to as plus bs. Then Okay, then if anybody is not following, you can stop me. Fine. Then substitute s equal to 0. We will get omega n square equal to 0 plus c omega n square, implies that c is equal to 1. C is equal to 1. Let us find a and b. So for that reason, I will put omega s equal to 1. So I'll substitute s equal to 1 in this equation. I will get omega n square equal to a plus b plus c omega n square, and the value of c is already known. It is unity. Similarly, substitute s equal to minus 1, omega n square equal to a minus b plus c omega n square, because we have a square here. So again, c is unity. So I can make any mathematical step, either addition or subtraction. So we should get the answer. So please try it yourself. Don't just look at this derivation. If I am wrong, you can correct me. And I hope, yeah, that's correct. A is minus 1. So that is one way to calculate. You can calculate by another way also. So just for the people who find difficulty, can follow any of the method. So I'm simplifying the first equation, and I get a plus b equal to minus 1. Okay, that's fine. Similarly, write the second equation. I'll name it the first equation as star, and similarly the second equation is omega n square equal to a minus b plus 1. So again, omega n square will vanish. So we have a minus b equal to minus 1 now. This cross verify. So this let be double star. Solving star and double star, we get a equal to minus 1, which is same as the previous solution. And when a is minus 1, you can substitute that value anywhere here. You will get b equal to 0. Yes. So a equal to minus 1, b equal to 0, c equal to 1. C equal to 1. So some students might be finding difficulty in writing these things, because every time you have to look at the screen and then you have to make a copy of it or solve. So please, I suggest you to go through the videos again and again, or if possible, you can take the screenshot and save them appropriately in your laptop or computer. So just look at the screenshot and then you can understand. But by any chance, don't just look at the videos without making a write up or without making a note, because it makes you to feel that you have understood everything, but when you actually write in the exam, the complexities will start. So please practice the derivations either by looking at the videos or on your own, but don't just watch the videos and leave as it is. Fine. So we found a b c values, and I will substitute them here. First I'll substitute c, then as plus b is left. So a is minus 1 minus s plus b is 0. So it is just minus s plus 0 in the numerator, divided by square plus omega n square. So we have s 1 by s minus s divided by s square plus omega n square. So this is c of s, and c of t is very simple. It's a direct Laplace inverse identity. You can find it in list of Laplace inverse expressions. This is equal to cos omega n t. S divided by s square plus omega n square is cos omega n t. So I hope there is no doubt regarding this. Next job is how the graph looks like. Same procedure has to be applied. Can anyone recall what kind of graph we had got for undamped behavior? Can anyone tell me?
Oscillating.
Oscillating. Can you remember the magnitude? Magnitude of oscillation.
No, sir.
Okay. Shalini Gupta. Because I'm finding some new name.
Yes, sir.
You're regular to class?
Yes, sir. I wasn't present for I think 3-4 days because I had supplementary exams on those days.
Okay, fine. Rudrash, are you regular? Rudrash Singh. Okay. Pranav. Pranav is there? Priyanshu. Priyanshu Sena. Priyanshu Sena. Present or not present or don't want to talk?
Yes, sir.
Priyanshu Sena, are you following?
Yes, sir.
Do you remember what was the nature of graph for this case?
Previous class I have not attended, so I don't know, sir.
Okay. Harsha Sedam.
Yes, sir.
You remember what was the nature of graph?
Yes, sir. But magnitude, I didn't remember.
Okay, that's fine. Abdul,
Yes, sir, I'm there.
how was the nature of graph? What was the nature of graph?
Oscillating.
It was oscillating, right?
Yes, sir.
Okay, very simple. So C of t we got here. And let us substitute the value of t here without making any calculation. So omega n is obviously some constant which is obtained by system dynamics. So as t increases, what is the value of this expression? That's what we need to check and plot it in the graph. So it's very simple. What is the maximum value and minimum value of the cos term? It is plus or minus 1. Fine. So
Magnitude 2, sir.
yes, the maximum magnitude was 2, minimum was 0. Fine. So let us see how it goes. It's very simple. If you look at the expression, you should be able to guess. Fine. So let us start with marking the input. Input is a unit step function, R of t. And when t is 0, what is the value of C of t? Is it 0? 1 minus 1. It is 0. Am I correct or any mistake? Okay, fine. So this is how it goes. Starts from 0, then continuous oscillations with a maximum magnitude of 2. Fine. So these oscillations will continue with a magnitude of 2 only. These oscillations will never decay. That's what this expression is telling us. Okay. So hope you can appreciate the beauty of mathematics. If you set up a system without friction, if you set up a system with a mass and spring only without friction, and if you apply a unit step force by your hand, the nature in which your actual system is moving is governed parallelly by this mathematical equation. So that's how physics and maths are correlated. And this is how the study of control system should go. You should never become a theoretical mathematician or only a physical scientist. Only a physicist. You should be both mathematician as well as a physicist. Then only your control system will be good. Otherwise, your control system will be bad. Fine. So that's what will finish my work. And this is it for today's class. We studied the first 3 scenarios of second order system, and we were equally able to give a mathematical expression for them, and we plotted the response for those mathematical expressions. What I would like to highlight again is when you look at this graph, you should be able to imagine the system. not like the exact structure, but the dynamics we call dynamics. So when I show you this graph, you immediately should guess the system is continuously oscillating. Continuously oscillating, and there's something wrong because the oscillator behavior is not acceptable at all, right? Suppose imagine you push a door which is attached to wall through a spring hinge, and if you push the door while going outside, okay, and your door is giving this type of response, what will happen? Just imagine. Everyone in the hall will look at you only instead of door. Right? So when such response will come, how to take care of such responses? Is it acceptable? Is it not acceptable? So all those things will be analyzed further. So I hope I'm able to convince the things. Any queries till this point? Any queries till this point? Those who are missed the classes of this chapter, please refer the videos. It's very important in all aspects, not only in control system point of view, but this mathematics, the mathematics whichever we have derived, it's very important. It may help you to make analysis in some systems in other domain other than control system also. Okay, so that's it for today's class, and tomorrow we may have a discussion class or a revision class or a query solving class. If there won't be any query, then I will proceed with the last case of a time domain analysis of second order system. Okay, so thank you one and all. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, bye.
Sir, there will be no numericals from the second unit, right?
Hello? Yeah?
Hello, yes, sir. Aditya this side.
Yeah, tell me, Aditya.
Sir, there will be no numericals on the second unit, right?
There will be why?
Sir, only the rise time and for second order also will have, sir.
No. There won't be numerical in the second order case about time domain specifications. Okay, but you may get something else related to that within the limit of whatever I taught. That I will assure.
So derivation can also be asked.
Yeah, why?
Okay, sir. Okay.
I will ask.
Okay, sir.
Any queries? Okay.